A tower stands vertically on the ground from a point on the ground which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is 60. Find the height of the tower. So here we have a tower, which is AB, and from a point 15 meters away, so I'll take a point 15 meters away, that is point C. So this distance now is 15 meters. The angle of elevation of the top of the tower is 60. Now when I'm drawing angle of elevation, first I have to draw the horizontal, and then you have the line of sight. This angle is angle of elevation. So my horizontal I have already drawn. This is my horizontal here, and this is the line of sight. Here is a line of sight. I'm looking at the top of the tower. This angle is 60. I need to find the height of the tower. So this is my H. Here is my tower. So this is the H. So I'll consider triangle ABC, and in triangle ABC, AB represents the tower, C is the point of observation, now in this the perpendicular is AB. Here is a perpendicular, and BC is a base. So the theta is 60, perpendicular is AB, which is H meters, we don't know, and the base is BC, which is 15 meter. So I will start with 10 theta. 10 theta is perpendicular over base, and 10 of 60 equal to perpendicular. The perpendicular here is AB, and the base is BC. So 10, 60 is root 3. Root 3 equal to AB over BC is 15. So AB, which is the height of the tower, is 15 root 3 meters. So height of the tower is 15 root 3 meters. An electrician has to repair an electric fault on a pole 5 meters. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. What should be the length of the ladder that she should use, which when inclined to an angle of 60 degrees to the horizontal would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? So here we have an electrical pole which is 5 meter tall. So our electrical pole is represented by AD. So this is AD, the electrical pole. Now this electrician has to repair, and the fault is not at the top of the pole, but the fault is 1.3 meters below. So the fault is at point B here. Here is the fault at point B. So this height is 1.3 meter. The entire AD is 5 meter. So that means our dB, this dB from here to here, will be 5 minus 1.3, that is 3.7 meter. Next they said what should be the length of the ladder. So here is a ladder, and we need to find the length of this ladder. This is the ladder. So let's draw it again. This is the ladder. We have to find the length of that ladder. If the angle of elevation is 60, the angle the ladder makes with the horizontal is 60. So this angle is 60. So we let the ladder be, say, L. We don't know the length. So here we take the triangle, we join this. Here we are taking the triangle BDC. In this triangle we know AD represents ladder, and we have BD equal to 5 minus 1.3, which is 3.7 meter, and this is the perpendicular. Here this is perpendicular, this is the base, and here is the hypotenuse. So BD is a perpendicular, then we have BC is a ladder, represents a ladder, which is L, and you don't know, and this is the hypotenuse. So we have perpendicular and hypotenuse. For perpendicular and hypotenuse we use sine. Sine theta is perpendicular over hypotenuse, and in this case it is sine theta, means sine of 60. Perpendicular is BD and hypotenuse is BC. Sine of 60 is root 3 by 2, and perpendicular is 3.7, that is BD, and the BC is the length of the ladder that we don't know, L. So L is 3.7 root 3 over 2. L is 3.7 into 2 over root 3. You rationalize it, you put the value of root 3, and the answer you get is 4.28. So the ladder, length of the ladder is 4.28. Now there's yet something else to find out here. Here they're saying how far from the foot of the pole should she place the foot of the ladder. So we have foot of the pole D, foot of the ladder C. So now we need to find out DC. So we are again taking the same triangle, that is BDC. The theta is 60, perpendicular BD, which is 3.7 meter, base DC, which we need to find. We're going to put it as X, and here we are perpendicular over base, so we do 10 theta, perpendicular over base, and this is 10 60, 3.7, base is X, that is root 3 equal to 3.7 over X. So X is 3.7 over a root 3. You rationalize, put the value of root 3, and you get the answer 2.14 meter approx. That is this distance from the foot of the ladder. An observer 1.5 meter tall is 28.5 meter away from the chimney. Find the angle of elevation of the top of the chimney from her eyes is 45. The angle of elevation of the top of the chimney from her eyes is 45. What is the height of the chimney? So first we have the chimney. So AB is the chimney, and there is this person or a girl who's 1.5 meter tall. So here is the girl, 1.5 meter tall. She is 28.5 meter from the chimney. So B is the foot of the chimney, and this is the girl, and the distance between them, this distance BC, is 28.5 meter. The angle of elevation is 45. So to draw angle of elevation, first I must draw the horizontal. At a eye, this is the horizontal here, and here is a line of sight. This angle is 45. I must find the height of the chimney. So I'm going to take the triangle ADE. Take this triangle. In this triangle we have the angle 45, and if angle is 45, here is the perpendicular and this is the base. So we start triangle ADB. Theta is 45 degrees, perpendicular is AB, and the base, not AB, AE is the perpendicular. AB is the entire, AE is a perpendicular, and the base is DE. Now look at AE. AE is the entire, this full thing is 28.5. Here we need to find AB, right? So we know that DE, this is X, we don't know. Our DE is 28.5. So we have perpendicular base, we do 10. Then theta is perpendicular over a base. So 10 45 equal to perpendicular, which is AE, and we don't know that, base 28.5. So 10 45 is 1 equal to AE over 28.5. So AE is 28.5. So we found our AE from here. This is 28.5 till here, and this little part is from here to here is 1.5. Therefore the whole chimney, the height of the chimney, will be AE plus BE. AE is 28.5 and B is 1.5, so that comes to 30 meters. So the height of the chimney is 30 meters. From a point P on the ground, the angle of elevation of a top of a 10-meter tall building is 30 degrees. Our flag is hoisted at the top of the building, and the angle of elevation of the top of the flagstaff from P is 45. Find the length of the flagstaff and the distance of the building from the point P. Let's mark the first part. From a point P on the ground, the angle of elevation on the top of a 10-meter tall building is 30 degrees. So here is the building, and they said the building is 10 meter, so I will mark 10 meter here. This is 10 meter. From a point P, you've got to mark a point P. So this is P, and the angle of elevation is 30, they said. So for elevation, first I draw my horizontal, and here is the angle of elevation at the top of the building. So this is the angle of elevation. This angle here is, I cancel this angle is 30. So in this triangle, here is my perpendicular, this is my base, and I go ahead with the sum. So theta is 30, we have the perpendicular, which is AB, and the base AP. The perpendicular is given as 10 meter, the base we need to find. So we do 10 theta is perpendicular over base, here 10 30 in this case, perpendicular 10, base we don't know, base is AP. 10 to 30 is 1 by root 3 equal to 10 over AP. So we have AP equal to 10 root 3. Now let's get on to the next part of the sum. Now in the next part they said a flag is hoisted at the top of the building. So here is the flag that is hoisted at the top of the building, and the angle of elevation of the top of the flagstaff from a point P. So from the same point P, Now I'm looking at the top of the flagstaff. Now where is the top of the flagstaff? Here. This is the top of the flagstaff. I will put it as, we'll mark it as D. So when I look here at the top here of the top of the flagstaff, here the angle of elevation, now this is the angle here with the horizontal, this angle is 45. So this is our base. Here we have the perpendicular. This is perpendicular. This entire is perpendicular, and this is base. So we take triangle PAD, theta 45, perpendicular we see is AD, and base is AP, which we don't know. Now how much is AD? AD we have already found out. We know this is 10, which is given to us, and we will take this part as x. Yeah, this is x. So the entire AD equal to 10 plus x. Now we have perpendicular and base, so we'll take 10 theta, perpendicular over base, and 10 of, here we have 45 is the angle, equal to perpendicular 10 plus x over AP. But AP we already found here 10 root 3. So I'll write here 10 root 3. 10 of 45 is 1. So 1 equal to 10 plus x over 10 root 3. When we cross multiply, I will do it here. So you have 1 equal to 10 plus x over root 10 root 3, cross multiply, 10 root 3 equal to 10 plus x. So x equal to 10 root 3 minus 10. 10 common out, root 3 minus 1 equal to x. You put the values, you get 10 into 0.732 equal to x. So x equal to 7.32 meters. That's the height of the flagstaff. So in this sum, first you took up this triangle, and from this triangle, this side, the perpendicular was given to you, this was given to you, this side, this was given. Then you found out AP. Then you took up this entire triangle. And find out this x. The shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 than when it is 60. Find the height of the tower. So here the sun is at two positions. First, you can say the sun is at this position here. And when the sun is in this position, the angle of elevation would be, always draw horizontal first, and this would be the angle of elevation when the sun is at 60. Then after some time the sun would come down, and maybe it would be, say, at this position now. So now the angle of elevation would also change. So here is the horizontal, and this would be the angle of elevation now when the sun is at this position, and this angle is 30. Now that is, as the sun goes down, the shadow gets longer and longer. To explain this, let me draw one figure here. Here's the ground. Suppose I have a tower here, and if the sun is at this position, to find the length of this tower, you will have, here is the sun, this is the angle of elevation, this would be its shadow. But now if the sun now goes down, See, the sun is here now. Now where would be the shadow? You would get it somewhere here. This would be the shadow, would get longer. So as the sun goes down, the shadow gets longer and longer. If it's somewhere here, it will be, this would be the shadow. That's exactly what we're doing in this sum. In position 1, the shadow would be BC. Here is the shadow BC here. And when the sun is now in position 2, the shadow would get longer. And the shadow would be this entire DC here. And they said it is 40 meters longer. 40 meters longer means this distance is 40, the difference between two shadows. Let me explain this concept again. So if the sun was in this position, say 1, the angle of elevation would be here 60. This would be the angle of elevation, and here would be the shadow. BC would be the shadow. So when theta is 60, the shadow is BC. Now the sun goes lower down, say position 2, and now the angle of elevation is 30 because the sun has gone lower down. I think I put it in blue. So here is the angle of elevation, a little lower, which is 30. And now the shadow is this entire dB. So when theta is 30, the shadow is BD. Here they said the shadow is 40 meters longer. So the difference in the shadow is 40 meter. The longer shadow is BD and the shorter shadow was BC. And their difference is 40 meter. And if you look up in the figure, what is BD minus BC? Look up and see. BD minus BC is DC. So your DC is equal to 40 meter. This is important, that DC is 40 meter. Now we do the sum as all the other sums. We take up the first triangle. Here, this is the triangle ABC. This is perpendicular. Here is base. So my perpendicular is AB and the base is BC, and I use tan theta. So tan theta perpendicular over base, and this would be now tan theta is tan 60. Perpendicular AB, we don't know. We put this as H, AB as H, the height of the tower. So we'll make this as H. And BC we don't know. We put this as X. So over X. So this is X. And tan theta is root 3. So root 3 equal to H over X. So we get our H as root 3x. This is one part. Now take up the next triangle. The next triangle we are going to take up is ADB. So in triangle ADB, now this will be a perpendicular, and BD will be the base. Remember, this we have taken as X. So perpendicular is AB, which we took as X, and base is BD, which is X plus 40. Fine. Let's go ahead and do the sum now. We have tan theta perpendicular over base, and tan theta means tan of 30 perpendicular H, and the base is H plus 40. So here we had got our h as root 3x, and we said tan theta was tan theta is tan 30 equal to h over x plus root 3. Tan theta 1 by root 3. H is root 3x. So for h I am putting root 3x over x plus root 3. Cross multiply. So we have x plus root 3 equal to root x into root 3x. So x plus root 3 equal to 3x. This is 40, x plus 40. So plus 40, cross multiply. X plus 40 equal to root 3x. X plus 40 equal to 3x. So 40 equal to 3x plus minus x. So 40 equal to 2x, x equal to 20. So this is x. Now we know the height of the tower is x root 3. We found x as 20. So 20 root 3 is the height of the tower. The angle of depressions of the top and the bottom of a 8-meter tall building from the top of a multi-story building are 30 and 45 respectively. Find the height of the multi-story building and the distance between the two buildings. So first here we have two buildings. One is building, the small building AB, and then we have the tall multi-story building which is PC. This is the first part. AB is the building. AB represents the building, which in this case is not very tall, 8 meter, and PC represents the multi-story building. Which we do not know the height. Now let's read the first. First they said the angle of depression of the top and bottom of the 8-meter building from the top of a multi-story building is 30 and 45. So where is your point of observation? Ask yourself this question. Where are you standing and observing? You are standing at P. Your P is a point of observation. So we write here P, point of observation. You got to ask yourselves questions as you do the sums. From this point P, what are you watching? You are watching the top. We'll do that again. You are watching the top of this 80-meter building, and when you're watching the top, you're making an angle of one angle you're making 30, one angle you're making 45. So from the top now, I'm going to watch the top of this building. So this is the top of the building, and here is the bottom of the building. So let me, from here, line of sight, top here, I'm watching here. This is my line, top of the building. And for me to draw the angle of depression, I'm looking down, so I'm making angle of depression. How do I mark angle of depression? Horizontal. This is horizontal with the line of sight. This one. So here I have to draw the horizontal. So this is my 30 degrees. This full angle is 30 degrees. You agree? This also will be 30 degrees because it will be alternate angles. I've marked one. Now I have to mark this 45 degrees. For 45 degrees, I'm looking at the bottom of the building. So let me look at the bottom of the building. From the top here, I'm looking at the bottom. This is the bottom of the building. Here. This is my line of sight. From the top, from the point P, I'm looking at the bottom of the building. Now again, to draw the angle of depression, first I need to draw horizontal. And then is my line of sight. So where is my horizontal here? This is my horizontal. PQ is a horizontal. And here is my line of sight. So this entire angle is 45. This blue angle is 45. If this is 45, here also will be 45 by alternate angles. So this is the sum, this is the diagram. Now we got to draw, or we got to solve the sum. We just take up two triangles and we go ahead. So here is the diagram. Now I'm going to take the angle with 30. So see what, I rub out everything else. I just get rid of everything and I only take the 30. In fact, I'll rub this too also, and I'll just take the 30. Where was my 30? Here was the line of sight. By alternate angles, I got this 30. So I'll take up this triangle. This is the triangle with 30. This is a perpendicular. Here is a base. And let me start. We have triangle BPD. Theta 30. I have to mark my perpendicular, mark my base. Perpendicular PD, which I don't know. And base also BD, which also I don't know. Right? But I'll put my BD as PD as X here. I'll put this as X. And I'll start with my 10 theta perpendicular over base. So 10 of 30 perpendicular PD and the base BD. 10 30 root 3 1 by root 3 PD X, BD don't know. So BD equal to root 3x. I'll just keep this here. Now it's time to take the other triangle, and the other triangle was 45. If you remember, this was 45. So this was the other triangle. Here was my other triangle. So I'll erase the other parts out. So I erase this up. So this was my 45. I'm going to take up this triangle. Here is my perpendicular, which is made up of X. And if you remember, this was 8 meter. So this also will be 8 meter here. Perpendicular, this was base. So now I take up triangle PAC. Theta 45. I need to denote perpendicular, base. It's standard for all the sums. So perpendicular is PC. And you see PC is X plus 8. Base AC. So we do 10 theta perpendicular over base, and 10 45 perpendicular PC base AC. So 1 equal to PC X plus 8 AC. Okay, so AC equal to X plus 8. This is the second equation. Look up in the figure and see the relationship between BD and AC. And if you see, you will have noticed that BD is equal to AC. So this is my key. BD equal to AC. The next thing I'm going to do is BD equal to AC. So in the figure we saw that BD was equal to AC. BD was under root 3x and AC was X plus 8. So we solve this. Root 3x minus X equal to 8. You take X common out. Root 3 minus 1 equal to 8. So X equal to 8 over root 3 minus 1. We rationalize 8 over root 3 minus 1, multiply it by root 3 plus 1, multiply this also, root 3 plus 1. So X equal to 8, root 3 plus 1, A plus B, A minus B, root 3 square, 1 square. So X equal to 8, root 3 plus 1 over 2. So X equal to 4, root 3 plus 1. So now we have to find the height of the building. Now this was already 10 meter. And here we found this was 4, not 10, this was 8 meter, right? The building was 8 meter tall. 8 meter, and this was 4 root 3 plus 1. So the total height of the building is 4 root 3 plus 1 plus 8. 4 root 3 plus 4 plus 8. And if you add this up, 4 and 8, you will add 4 root 3 plus 12 was the height of that multi-storied building. And to find the distance between the building, this AC was the distance between the building. And you saw AC, we have found AC. AC was root 3x. AC was equal to BD root 3x and root 3, and we saw that the x was 4 root 3 plus 1. So that is 4 root 3 plus 1. So that will be 12 plus 4 root 3 would be the distance between the building. From a point on the bridge across a river, the angle of depressions of the banks of the opposite sides of the river are 30 and 45. If the bridge is at a height of 3 meters from the bank, find the width of the river. Here let's mark the river first. We have the river is AB, this is the river, and this is bridge over the river, and we are standing at a point on the bridge. So a point of observation is here P. And from P we are looking at the banks of the river. Now there are 2 points on the banks of the river. One is A and the other one is B. So from P, I'm at the top. So if I look at the banks of the river, I'm making angle of depression. One angle is 30, other one angle is 40. So remember to, when you are drawing angle of depression, first horizontal and now the angle of sight. This is the angle of sight. So this angle will be 30, and if this is 30, you definitely agree this angle has to be 30 because alternate angles. The other angle of depression, they said, is 45 when we look at the other bank. So to draw any angle, first we mark horizontal and then the line of sight. We're looking down here at the other. This angle is 45, so this angle also will be 45 by alternate angles. So we have 2 triangles now. One triangle is this yellow one here. We will find the base and perpendicular. So we have triangle PAD. For PAD, here is perpendicular and this is base. So let's write that. Theta is 30. The perpendicular is PD, which we know is 3 meter, and the base is AD, which say we don't know it, we call it X. So we'll find 10 theta perpendicular over base, that is 10 of 30, perpendicular 3, base AD. 10 30 is 1 by root 3, so 1 by root 3 is 3 over AD, and I have my AD equal to 3 root 3. Okay, I keep this on one side. Now I'll take up the other triangle, the green triangle. Here is my green triangle. So I'll take up that. So triangle PDB, theta 45. I have to mark my perpendicular, base. Here perpendicular is the same, and for the base will be here. The perpendicular remains the same. So perpendicular PD, which is equal to 3 meter, base BD. Now we do 10 theta perpendicular over base. Here the theta is 45, so 45 perpendicular in this case is PD, and the base is BD. 10 45 is 1, PD is 3, and this is BD. So BD equal to 3, and this is important. Now I need to find the length of the river. Now this is river is AB of mine. Here this is my river AB, and you know AB, which is a river, equal to AD plus BD. Now AD is 3 root 3, which we found here, and BD is here plus 3. So we take common out, 3 common out, root 3 plus 1 will be the length of the river. So not the length, the width of the river. The width of river will be 3 into root 3 plus 1 meter.